So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with circle theorems, going over the other theorems that we didn't go through on video 1 on circle theorems, which is going to be the alternate segment theorem, diameter of a circle being the length of a triangle, and the tangent theorem, which acts as two theorems in one. Now we'll be going through some examples as well as giving you the definitions of each of these theorems. Now looking at our next circle theorem, we can see that we've got the alternate segment theorem. Now this one is the only, I would say the only sort of theorem that you can get away with just by saying what the title is. So if you are going to use the alternate segment theorem, just need to quote it. You don't need to kind of memorize what's in red. However, that would be absolutely fine if you did. And you may even be able to get away with using the abbreviation of AST. But again, I wouldn't be that lazy. I'd actually just write down the words of alternate segment theorem. Now, the important thing with the alternate segment theorem, and it's something that I constantly get confused with or get muddled up, is thinking that the alternate segment theorem is very much like alternate angles, which is like Z angles on parallel lines. Now, the key thing to remember here is that this angle that I'm just highlighting here on the tangent when it meets a triangle is going to be the same as this angle here. And the angle that meets the triangle with the tangent, this angle here, is going to be the same as this angle inside the triangle. And you always want to make sure that you are making sure you're remembering that, because like I said, commonly you would automatically think, and a lot of people make the mistake of thinking Z angles, so this angle here, the 80, would be the same as this angle here, but it's not. So it's really important that you don't get those two confused. So let's have a look at some example questions. So again, the orientation of the circle and the tangent and the triangle may be different, but the concept is still the same. So here, looking at question A, this angle here, which is marked as 70, is going to be the same as this angle here, and this angle here is going to be the same as that interior angle on the triangle. So for part A, x equals 70 degrees. Now with the second one, with B, again, if I just kind of colour in the angles that are going to be the same, so those two blue angles are going to be the same and these two green angles are going to be the same. And by just noting that down, and whenever you see an alternate segment theorem, I always try and use coloured pens or use shading on a pencil or a pen to just map out which angles are going to be the same without even thinking about what the question is going to be, just so I know that when I do go to work it out, it's going to be fine. So here, x is going to equal 55 degrees and y is going to equal 60 degrees. And then moving on to question C. So again, if I straight away mark what these angles are going to be, so that angle is going to be the same as this angle here, and this angle here is going to be the same as that angle there. Now in this particular question, I've got to find x, y, and z. And again, although there's no law that says you have to do it in that order, generally speaking, that's usually the order that they go in. So here, x using the AST is going to be 65 degrees. Y is going to be 63 degrees, and then to work out what Z is, again remember that angles inside a triangle add up to 180, so it's going to be 180 minus 65 minus 63, which gives me 128. So 180 minus 28 is going to give me an answer of 52 degrees. So now let's have a look at our next circle theorem. So this is that the diameter triangle inside a circle is always going to be, so when you've got a diameter of a circle that represents the length of a triangle, then the opposite angle to that is always going to be 90 degrees. Now the actual definition for this is that the angle subtended at the diameter of a circle is always a right angle. So this angle here, if this is the diameter, so if a side of the triangle inside a circle is the diameter, then the opposite angle to the diameter will be 90 degrees. So this angle here would always be 90. So let's have a look at some example questions. So here we've got quite a few, so we've got 6 here. So again, typical markings of question A, so let's just work that out here. So with A, we know that opposite angles, that's representing the centre, because obviously O is the centre, so that means that this angle here is going to be 90, so X equals 90 degrees, and then to work out what Y is, that's just going to be angles inside a triangle, add up to 180, so that's going to be 12 degrees. So moving on to question B, again looking at, this is obviously the diameter, so this angle here is going to be 90, so X equals 90, and again remember the angles inside a triangle add up to 360, so that's going to be 44 degrees. And then looking at C, again diameter, so the opposite angle is going to be 90, so in this case X is equal to 90 degrees, and then working out what Y is, well, angles in a triangle add up to 360, so Y is going to add up to 63 degrees. And then looking at D, so again opposite angle to the diameter is going to be 90 degrees, so X equals 90, and then to work out Y, all they need to do is just do 180 take away 49, which gives me an answer of 41. Well, actually plus 90, don't forget, from 180. And then with question E, again opposite angles, so that's going to be 90, so X equals 90, and then Y is going to equal all those angles that's mentioned, that's worked out, take away from 180 gives me an answer of 52. And finally for F, I've got X, Y and Z, but it also I can see that the opposite angle, so this angle here is going to be 90, so X is going to be 90. Now because it's an isosceles triangle, those two other angles are going to be equal, so then it's just going to be 180 take away from 90 divided by 2, which gives me 45 degrees, and there's the answers for those questions. Now the next circle theorem, which is kind of a combination of two. So the one is that any two tangents from a single point are the same length. So if you pick a point outside of a circle and you join two lines so that they become the tangent of the circle, then basically these two lengths here are going to be exactly the same. And another rule for the kite or the tangent theorem is that the angle between the tangent and the radius meet at 90 degrees. So when you've got the radius of a circle, that will always meet a tangent at 90 degrees. So always 90 degrees these two are. So let's have a look at some practice questions of those. So looking at this, we can see that here is our radius. So that means that the angle that meets the tangent at that angle is going to be 90 degrees. So that's going to be 90. So if that's 90, then all I need to do is add up 90 plus 37, take it away from 180, and that gives me an answer of Y. So that gives me a Y answer of 53 degrees. Then for B, again, this is a tangent, so then all I need to do is just recognize that X equals 90 degrees. And then to work out Y, which is the length, now you can see that this is therefore linked with, because it's a right angle and I've got a triangle, it's going to involve Pythagoras. So for Y, we need to use Pythagoras. And so working out Y is going to be the hypotenuse, or C. So I've got 12 squared plus 5 squared equals Y squared. So it's 144 plus 25, which equals 169. So Y squared equals 169. So Y equals 13. And then moving on to our last question. So again, radius is this here, and we've got a right angle, so X equals 90 degrees, and then again I'm going to use Pythagoras as well. So for here, to work out Y, now in this particular case Y is the radius, but also the smaller side of the triangle, so it's going to be 18 squared equals Y squared plus 12 squared, and then rearranging that, I get 18 squared minus 12 squared equals Y squared. Now 18 squared minus 12 squared is going to give me an answer of 180, and so Y equals square root of 180, which I can simplify in third form as being 6 root 5, or I can write it as a decimal as 13.4 centimeters to one decimal place. There we go. Now, in the next video on circle theorems, I will go through some common exam questions and again, hopefully show you where and why you need to remember the definitions of the circle theorems, particularly when you're asked to prove that an angle equals a certain angle, or if you're given a reason as to why an angle equals that value that you've given.